exponential growth and decay. This comes from investigation 11 on page 749. As long as we have an interactivity here to use, we will go through the material. Exponential growth occurs when a quantity increases at the same rate r in each time period t. Y represents final amount in the equation you see here. A represents the original amount. R is the rate we just mentioned. T is the exponent on the outside here that represents time. Decay means we're decreasing, so it's just the opposite. Let's see what they've got for us.
Exponential growth occurs when a quantity increases at a constant rate. Suppose the number of mice in a field doubles every month. The population grows exponentially.
See how fast that population grows when you are multiplying by an exponent constant. Exponential growth means it increases more and more as you go along. It's just like when you you find something small like 2, but instead of times 8, you do it to the 8th power. And suddenly by the 3rd or 4th multiplication, you realize how fast you're growing because you're starting to use such huge numbers because you're multiplying by itself. So as soon as you get some big numbers, multiply that by itself, it grows immensely. And this is a zoomed out graph. Even at the beginning, it was growing fairly quickly, but we're able to see all the way up to 256 in just 8 months. Again, the x-axis is measuring months, and up and down, the y tells us number of mice. And I can tell you this is probably fairly accurate. Animals like mice, unfortunately, do reproduce rather quickly.
The equation for exponential growth is y is equal to a times the quantity 1 plus r to the t, where y is the final amount, r is the growth rate, t represents time, and a is the initial amount. Jaime and Elena Cortez own a sculpture valued at $8,000. Its value increases by 5% each year. Find the value of the sculpture after 15 years. Drag the values to replace the variables in the exponential growth equation.
So pretty easy. Original amount is A, time 15 years, T, rate 5%, so 5/100ths. You just plug them in.
Exponential decay.
I think we understand decay.
A butterfly population
it's just the opposite.
in a sanctuary is decreasing at a rate of 7% each year. The original population was 70,000. Find the population after 4 years. Drag the values to replace the variables in the exponential decay equation.
I think a big part of exponential growth and decay is recognizing that's what you're doing. To read a problem like an original oil painting is valued at $25,000. If its value increases 3% each year, in this case they make it easy because they tell you, but if they just said, find the painting's value in 5 years, you may not realize to use this handy-dandy equation, right? Now, A, which is the original value, we said the original amount would be the 25,000, right? Whereas R would be 0.03 and T would be 5. So in this case, 1.5% is rate. These are easy. Here we have to actually do something. So I'm on page 750 to find that equation. Maybe 749, they've got it. Where did it end? Oh, I see. If it's valued at 400 and it increases, we just maybe found the increase amount. Sorry for the confusion. I used the decay equation. It should be y is 400